try and figure out and make sure that we don't have to have a graph in order to do a translation. So somebody tell me in words, what does x minus 4 mean? To the left 4. Very good. And what does y plus 2 mean? Up 2. Very good. Now, without a graph, if I were to start at 5, negative 2, what would my new coordinate be? Well, what they're asking you to do is that this is x and this is y. So I'm just going to plug in. If x is 5, what's 5 minus 4? 1. What is a negative 2 plus 2? 0. So my new coordinate is 1, 0. I don't have to actually graph it and move it. Are we okay? Then right here, they want you to find an image, 3, 2. And they want you to reflect it over y equals negative x. Some of you, that negative throws it off. Okay, let me ask a question. If I say y is equal to x, if y is 1, what's x? 1. If y is 2, what's x? 2. Yo, this right here is the exact same thing. They just put a negative in front of the x. So right here, if y is 1, then x would be a negative 1. If y is 2, then x would be a negative 2. And if I converted that into a coordinate, x goes first, right? So this would be negative 1, 1, negative 2, 2. I know last year in Algebra 1, before you got going on your EOC stuff, they talked to you about parent functions, and y equals x is one of those parent functions, right? This is not new to you. So if I were going to graph this, negative 1, 1, negative 2, 2, it would then be negative 3, 3. This line right here is the line you're trying to reflect over. In the past, when we were doing reflections, I said you just count over. 1, 2, 3, 4, 5. But can I just keep going over 5? Remember when we talked about that heart? If I folded a heart in half, that creased paper, I want the same on both sides? The crease is this blue line. If I crease this paper right here, would this point sit on top of that point? No. That's why I know that's not the answer. If I go up 5, is it on the other side of the blue line? No, I want it to be on the other side. So right here, I would have to go down 5. Does this point look like when I folded it, it would be sitting on top of that? Are we okay? So my answer for this problem would be negative 2, negative 3. And then I also talked right here, this point would be negative 2, negative 3. And they want me to reflect it over x equals 1. Some of you are confusing these two problems together. This one right here says that I want the value of x to be 1. So when I do coordinates, this is a 1. What am I? I don't know. Do you know? So make something up. 1, 2, 3. All they told me is I want x to be 1 for absolute positive. So if I graph this point, 1, 1 is right here. 1, 2 would be right here. 1, 3 would be right here. If I connected them, that makes this line right here, wouldn't it? So now I need to reflect that point over this line. This is where I count over 1, 2, 3. So I'm just going to keep going 1, 2, 3. If I crease it along that black line right there, do they look like they would sit on top of each other? Yes. Okay, and then the next step, because it says and then. Remember when we were doing the turtles and you had to reflect it and slide it down? Okay, this is what called a composite transformation. Now it wants me to reflect it over the x-axis. When somebody gives you directions to their house, they say go to this street and turn right, and then go to this next street and turn left. So do you go to that street and turn right and then go back to the beginning, and then go and turn left? No, neither would you here. So here, the first set of directions are reflected over this one, and then reflected over the x-axis. This is my x-axis. I'm not going to reflect this point. I need to reflect this point right here. 1, 2, 3, 1, 2, 3. That point right there would now be my answer to this question, which is at what? 4, 3? Are we good? Questions? No. So on this first one right here, did I go clockwise or counterclockwise? Counterclockwise, how far? 90 degrees. Because I move this way, that's counterclockwise. It goes in the opposite direction of the hands of the clock. Okay, on the next one, clockwise, counterclockwise. Clockwise, how far? 270, okay, because watch, if here's my flag, I go this way would be 90, I go this way would be another 90, which is 180, so I go another 90, okay, and that would be 270, so my ending arrow should look like this. We okay? Okay, on number 3, clockwise, counterclockwise. How far? 90 degrees, and my ending one should look like this, correct? Okay, starting on number 4, I'm tricking you, so you have to be careful. Clockwise, counterclockwise.
Clockwise. And you can go either way. Yes.
How far did it go? Okay, so we all agree on 180, right? It could be either. Because if I start here and I go 90 degrees, wouldn't it put it here? And another 90 degrees would put it here, wouldn't it? Well, what happens if I went the other way? If I started right here, I went 90 degrees, wouldn't it put it right here? And then if I go another 90 degrees, wouldn't it be exactly the same?
Yep.
So when we go 180 degrees, it doesn't matter whether we go clockwise or counterclockwise. That one is both. And here's my favorite one that tricks you, number 5. Hey, is my flag standing up or down?
Down.
It's facing
Down.
down.
The original one's down.
It goes up and
No,
then it
the
goes
original
90
one
degrees
is up.
down.
Up.
The original one is up.
Okay,
No,
here's what tricked you. This is my ending position, and we are going counterclockwise. So that's where it ended, and counterclockwise
Down.
is this way.
Down.
So to find out where it came from, we would have to go clockwise, right? So it came from this position right here, and then it moved counterclockwise to get to this position right here. Understood?
Yes, ma'am.
So this one right here should absolutely be down, pointing downwards. I told you I was tricking you. John White won a gold medal for snowboarding in the 2010 Winter Olympics with his signature move, the double McTwist 1260. Where does the 1260 come from?
All the time they spin around.
All the times he spun around. How many times did he spin around?
4.
4? Do you agree? How would I figure it out?
You see what
Oh, you did.
the number divided by 360.
Good. So what's 1260 divided by 360?
It's not even.
It's not even. 3 what? 3.5.
Rounds up to 4. Right?
Nope, 3.5. I don't know, if I spin 3.5 times around, does it really mean I spun 4 times around? No. Rotating still. We're rotating 90 degrees. The key to look for is that it says we're going to rotate about the origin. What's the origin?
Zero.
0, 0.
Darn it.
Okay? Here's the good news. If I'm rotating, and it only works when it's about the origin, all I have to do is turn my paper. So here, I want to turn my paper 90 degrees clockwise, correct? So if this were my paper, and I need to rotate it 90 degrees clockwise, those are going to be my new coordinates. Well, it actually gets even easier than that. Because right here, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? What's your coordinate for A prime now?
2, negative 1.
2, negative 1. What about B? C?
Oh, 5, negative 1.
Negative 1.
2, negative 3. Y'all look at these numbers. What do you mean they're the same? They're not the same.
They just flipped.
Yeah, there's
It's called
there's a Y sign change.
So not only do I know that I can just turn my paper to figure out what the new ones are, but really what had just happened is the Y's became the X's and the X's became the Y's. Now, with the positives and negatives, just look and see what quadrant should it land in and use those. So in this one here, it landed in this quadrant, which is a positive, negative number. So these should be positive, negative. Just go by which quadrant it should be landing in. So rotate your paper, the second one, and look and see if you can figure out what the new... Okay, so if you just rotated your paper, then here are my new coordinates. And a lot of you are stuck because I told you that you just float every 90 degrees, you just switch them. So you just came over here and switched them, but I tricked you because this one is going 180 degrees. What I told you was every 90 you switch them. So if I went 180, that's 2 90s, right? So I switched and then I have to switch it back. So really it just stayed the same. And now I know that it landed in this quadrant, which makes it a negative number. Now, without moving your paper, I want you to try this third problem right here. I want you to guess, what do you think this one would be without rotating your paper? Okay, so on this one right here, it tells me to rotate 270. So how many 90s are in 270? 3. So that means I'm going to take my coordinates. I'm going to, when I rotate 3 times, when I rotate once, I'd flip. Rotate again, I'd flip back. And then here would mean that I would flip them again. So I'm going to flip my numbers. So you should have had 2, 1, 5, 1, and 2, 3. But now what kind of number goes in this quadrant? A negative positive. Because every 90 degrees they flip. So here you would flip them. So it would be 2, 1. You're going to flip them back to be 1, 2. And you're going to flip them again right here to be 2, 1. And then you just have to look to see what kind of numbers go in that quadrant. Make sense? Okay, the difference. Up there, you were rotating around the origin, which is at 0, 0. Now, we're going to rotate, but now we're rotating around this point right here. Okay, I can't just turn the paper. Okay, visually, this is what it looks like. If I'm going to rotate it, I have to rotate each point. So I'm going to draw a line from P to A. Can I rotate that red line 90 degrees clockwise? Yes, it would come straight down, correct? Good, so right here would be my new point, A prime. So A prime is negative 1, 0. That's a 0. Okay? Now I need to go do the second point. So if I rotated the second point, I would do C from P to C. Can you rotate the green line? If I rotate that green line 90 degrees, wouldn't it go straight down? Mm-hmm. And it would be 4 units, right? So this right here is my C prime, which is negative 1, negative 2. Everybody good? Here's the part where it starts to get a little tricky. Now I need to do B. Well, here's P, and here's B, correct? I can't make a straight line like I did before. So what you're going to do is you're going to create L's. So if I did that, here's my L from P to B. Can you visualize rotating that L 90 degrees? Right? And you can use your hands, put your hands up there and rotate them around to see. We've already rotated this little line right here, haven't we? It's right here. So that means if I rotate it, that means it needs to stick out to the right. How many? 3. So down 2 over 3. This point right here is now my B prime, which is at 2, 0. Now, I'm going to get rid of some of these lines just so you can visualize your shape. Does it look now that this shape is that shape rotated around? Like those little pinwheels you spin in the, or you blow into and they spin around? Okay? So right now, show of hands, how many of you get this? Okay, there are some of you in here that are going, I have no idea what you're talking about. Okay, so I want to show you the algebraic way. And what it's doing is it's going back up to that origin thing. Because that origin thing was easy, wasn't it? So I'm going to start with 1 point. Let's start with A. The coordinate for A is 1, 2. Everybody got that? Now, I have to rotate it around point P. Point P is at negative 1, 2. But in order to use that origin thing, I can't rotate it around that point. I have to rotate it around the origin, right? So if I move this point back to 0, 0, okay, then I can use that origin thing, right? So let's subtract this. I'm subtracting it from here, and I'm using that coordinate. Everybody got that? So what is 1 minus a negative 1?
0.
2? Right? And then 2 minus 2 gives me 0. So now I'm back to that origin thing. If I'm going to rotate it 90 degrees clockwise, don't I just switch the coordinates? So now I need to switch the coordinates because I can rotate it like we did in that first unit.